Hi everyone. This is example 6 from chapter 17 in your student packet. It says, in the morning class, the mean on the first exam was 78 with a standard deviation of 2.3 for the 57 students in the class. In the afternoon class, the mean was 81 with a standard deviation of 5.7 for the 37 students in that class. On average, did the afternoon class score better than the morning class on the first exam? Looking at this problem, I want you to see that there are two samples. They are independent of each other in that there's no students within each one, none of the same students. But we're really looking to see if 81, an average of 81, is statistically significantly higher than the average of 78 for the first class. So I'm going to, notice we're talking about mean, so I'm going to let mu1 represent the average of the morning class. And mu2 is going to be the exam average of the afternoon class. And our hypotheses are, the null hypothesis is that there's no difference between these two, that their means are really just too close to say that there's a significant difference. The alternative hypothesis is that the afternoon class is doing better than the morning class, which means the morning class average is going to be smaller than the afternoon class average. And then we're going to run a 2-sample t-test. So if you go to stat tests, and it should be number 4. Yeah. We're going to use statistics since we have stats for each sample. The first average is 78. The standard deviation for the first sample is 2.3, and the sample size for the first sample is 57. The sample average for the second sample is 81. The standard deviation is 5.7, and the sample size is 37. We are looking to see if mu1 is less than mu2, and we're always going to choose no for pooled. So in this class, we always choose no. And when you hit enter, we get a test statistic of t equal to negative 3.045 and a p-value of 0.002. And so you can see that our test statistic is very significant. The p-value is very small, which means that there is a statistically significant difference between our averages, and that the morning average is statistically significantly smaller than the afternoon average. So our conclusion would be that since the p-value is below alpha equal to 0.05, we reject the null hypothesis and conclude that the afternoon class performed better on exam 1 than the morning class.